Welcome back, my dear students. Now let us start a new discussion on the topic of composition of coplanar non-concurrent force system. So what is this coplanar non-concurrent force system? So see here, as the name indicates, coplanar, right? As the name indicates, coplanar means the forces in the same plane. So now non-concurrent, okay, here you add concurrent, so non-concurrent. Okay, non-concurrent means the forces which do not meet at a point. Okay, do not meet at a point. So in a hurry I am writing. Okay, so the forces, the system of forces which are in the same plane and which do not meet at a point are called as coplanar non-concurrent force. Okay, I'll read the definition and I'll let you know. Okay, the forces acting in the same plane and not meeting at a point are called as non-concurrent force system. The force acting in the same plane, coplanar, and not meeting at a point, non-concurrent. If they are meeting at a point, it is concurrent, right? Now I'll tell you the example. So let this be a plane. Okay, so I'll take four forces. So this arrow, this is F1 force, F2 force, F3 force, F4 force, like that. See here, these forces are in the same plane but they are not meeting at a point. And you can take like this also, if this is the plane, so one force like this side, another force like this side. So these forces are in a same plane but they are not meeting at a point. So this type of forces are called as coplanar non-concurrent force system. Okay, they are not meeting at a point. So this type of forces are called as a non-concurrent force system. Now we'll see moment of a force. What is this? You already know what is moment. So what is the moment? Moment of a force. So what do you mean by moment? So moment is nothing but the force into perpendicular distance. So moment is equal to force into perpendicular distance, right? Force into perpendicular distance. So now when we come to this system of forces, okay, I'll define in another way, that is the moment of a force, the moment of a force, okay, the moment of a force is defined as the turning, okay, the turning effect, or rotational. The moment will make the body to rotate or it will make the body to turn. It's also called as rotational effect. The moment of a force is defined as the force which makes turning or rotational effect of a force about a point. Is called as moment of a force. So the moment of a force is defined as the turning effect or the rotational effect of a force about a point. So this turning effect or this rotational effect may be clockwise, okay, maybe clockwise or anti-clockwise direction. Okay, this rotational effect may be clockwise or anti-clockwise direction. For clockwise we will take it as positive, so it's our assumption. You can take vice versa also. And for anti-clockwise, we will take an assumption as negative. So the moment of a force is defined as the turning effect or the rotational effect of a force about a point, and this rotational effect may be clockwise or anti-clockwise. For instance, or for example, if I take a force like this here, if I take a force, so I'll take this point as O. So this is the point O and this is the point F1 force. Let this be the distance, perpendicular distance x1. Now this is just refreshing your knowledge. Now moment about O, if they ask, means moment about O means what we'll write, force into perpendicular distance, that is F1 into x1, right? So this way we will find the moment about O. Why I am telling this means, now we'll go to the Varignon's theorem. So in that they will talk about the moment. So you should know what is the moment. It is force into perpendicular distance. Okay, for about this moment of a force we will learn in detail in our module 4, okay, or in the module 3 in centered chapters or support reaction chapter. So in this moment you just see any moment about a, if the moment about point O means, so the force into its perpendicular distance. So now we will go to the another topic, that is Varignon's theorem. We'll state the theorem, we'll prove the theorem. Okay, in the next class we'll take about the problems on that Varignon's theorem. So now we will see what is Varignon's theorem. Okay, statement and prove Varignon's theorem. You can state and prove Varignon's theorem like this question you may expect in the exam. So statement: if a number of coplanar concurrent forces, okay, if a number of coplanar forces are acting simultaneously on a particle, okay, if a number of coplanar forces are acting simultaneously on a particle, then the statement starts: the algebraic sum of moment of all the forces, the algebraic sum of moment of all the forces about a point is equal to the moment of their resultant force about the same point. So what they are telling, that is moment of all the forces, like moment of the resultant force. So what is the moment? Moment means force into perpendicular direction. It is a rotating force or turning force, which we saw earlier. So moment of resultant force about a point, is equal to the algebraic sum of moments of all the forces about the same point. So the statement is telling that the algebraic sum of the moment of all the forces about the point is equal to the moment of resultant force about a point. So if we take R as a resultant, then if moment I want means, if R is a resultant, then moment means it should be multiplied by a distance about a point O, right? Now if R is the resultant force, then moment means force into perpendicular distance from the point, right, from O point. Okay, so let D be the distance. Okay, if R into D means this is the resultant of the this is the moment of the resultant, which is equal to the algebraic sum of all the moments. So it should be also moment, but it should be sum. Let F1 be the one force, so F1 into, let D1 be its distance, plus F2 be the another force, let D2 be its distance from the same point O. Okay, if I take O as a moment point, let F3 into D3. So how many force, it's not important, important is algebraic sum of all the moments. So this algebraic sum of this moment, and this moment. So force into distance is nothing but the moment, right? So m1, m2, m3. So algebraic sum of all the moment of all the forces about the same point, it is equal to its resultant. ಈ ಫೋರ್ಸ್ ಇಂದ ಬರೋ ರಿಸಲ್ಟೆಂಟ್ ಇಂಟು ಡಿಸ್ಟೆನ್ಸ್ ಮಾಡಿದರೆ ಏನು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೋ ಆ ವ್ಯಾಲ್ಯೂ ಈಸ್ ಈಕ್ವಲ್ ಟು ದಿಸ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ರಿಸಲ್ಟೆಂಟ್ ಇಂಟು ಡಿಸ್ಟೆನ್ಸ್ ಇಲ್ಲೇನು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೋ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ದ ಸಮ್ ಆಫ್ ಆಲ್ ದ ಫೋರ್ಸಸ್ ಇಂಟು ದಿಯರ್ distances, means sum of the moment of all these forces will be equal to the moment of resultant force of about the same point. So I'll give you the proof now. Okay, I'll just consider a force. So this is a force F1, let this is a force F2. So F1 ಮತ್ತು F2 ಫೋರ್ಸ್ಗೆ R ಅನ್ನೋ ಫೋರ್ಸ್ ಇರಲಿ, ಅದು ರಿಸಲ್ಟೆಂಟ್ ಆಗಿರಲಿ. ಸೊ ನಾವೇನು ಮಾಡ್ತೀನಿ ಈಗ, ಓಕೆ, ಅಟ್ ಅ ಪಾಯಿಂಟ್ ಎ, ಓಕೆ, ಕೋಪ್ಲೇನಾರ್ ಫೋರ್ಸಸ್ ಅಲ್ವಾ. ನಾವು ಐ ವಿಲ್ ಟೇಕ್ ಅ ಪಾಯಿಂಟ್ O, ಲೆಟ್ ದಿಸ್ ಬಿ ದ ಮೂಮೆಂಟ್ ಸೆಂಟರ್. ಓಕೆ, ಸೊ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ O and F2 be d2. The distance between O and R, so O and R, if I take the perpendicular distance, 1 minute, so this distance perpendicular distance, so this distance be D. For R the distance from O is D, and if I take the perpendicular distance from for F1 force, let this be D1. So let F1 and F2 be the forces and R be the resultant of those two forces. Okay, I'll write down. Okay, R be the resultant of these two forces. Now let D1 and D2 be the, I'll share you the PDF, this for instance only to see, be the perpendicular distances. Let D1 and D2 be the perpendicular distances of R, F1 and F2 respectively. Okay, now what we have to prove, in this condition what we have to prove, that R into D, R into the distance, so the moment R into D is moment of the resultant, is equal to F1 into D1 plus F2 into D2. So this we need to prove. Okay, what I do is I'll take a plane. So this is X and this is Y. I'll take a plane. Now I'll take this point A, right? So I'll introduce these forces in this plane. What I do, so this is the F1 force. Next, wait, this is F2 force, same that figure only I am writing here. This is the resultant force R. So let this resultant force be at an angle of theta from the X direction in the X plane. So this O I'll construct on the Y axis, so it will be here. Okay, O be on the Y axis. I'll join OA. So this is, I joined it. So now I'll take the perpendicular distance. Correct. So what I got is, these are all perpendicular to, So this is the perpendicular to F2, so that is D2. Now this is perpendicular to R, so this is 90 degree, so this is 90 degree, and this is D, and this is perpendicular to F1, so this is D1. Okay, no confusion, right? D1, D, D2. I have to what I have to prove? R into D is equal to F1 into D1 plus F2 into D2, which I need to prove. So now what I will do, you see, I take this triangle OAB. So I'll construct this. Let this be triangle OAB. So from, I'll take this triangle AOB, I'll write it here. So this, okay, so this is theta, so this theta and this theta is same from the basics. So A, B, and this is O, and this is 90 degree, right? Assume it. Then from triangle AOB, so from triangle AOB, what I need R into D, right? So R into D is equal to, I'll write R as same, into D. So we know that OB distance is D, right? Okay, so I can take cos theta is equal to adjacent D divided by OA, correct? Now what I want? D I want, that is OA into cos theta. Now I'll replace this D by this, that is R into OA into cos theta. So R into D, what it happen? R into OA into cos theta. Now I'll take this OA here first. So now concentrate, R into cos theta. See here, this is the force R, right? This is the force R, and it is, this is X, this is theta. If I resolve this into in X axis and Y axis, R is an inclination force, this would be R cos theta, and this would be R sin theta, right? R cos theta, R sin theta. So if I take, so this is what? This is X component, Rx, and this is Y component, Ry. So this is R in the direction of X, that is R cos theta. R in the direction of Y, this is R sin theta. Same concept. See here, OA I took here, so R into cos theta, R cos theta I'll take. Now what I'll get? This OA into R into cos theta is nothing but the horizontal component of the resultant R. So I'll take R into X. Horizontal component of R in X direction means it is horizontal. So R into D is nothing but OA into R into X, means R into subscript of X means it is an component of R in the direction of X, means that is horizontal. I'll take it as equation number 1. Okay, now I'll, oh, sorry, 1 minute. So what we got? That is R into D is equal to, R into D is equal to OA into Rx. We took as equation number 1. This we got. So if I'll write one statement, if R subscript of X denotes component of R in X direction, correct? Component of R in X direction. Similarly, if F1x, okay, force 1 x and F2x are the component of F1 and F2 in x direction, right? If Rx denotes the component of R in x direction, in same concept, this F1x and F2x are the component of F1 and F2 in x direction. Then we can write, what we can write, this F1 into D1. What we have to prove, this F1 into D1 is equal to, similarly as in this concept, same, is OA into F1x. Same concept, F1 into D1 is equal to OA into F1x, and this F2 into D2 will be OA into F2 subscript of x. So this is equation number 2, this is equation number 3. By the same concept as we did for resultant, F1 into D1, if we calculate in the same manner, we will get OA into F1 of x, F2 into D2 is equal to OA into F2 of x. Okay, now what I do is, I'll add equation 2 plus equation number 3. What I get? So adding how the equation, LHS plus LHS, RHS plus RHS. So F1 into D1 plus F2 into D2 is equal to OA into F1x plus OA into F2x. Then what I want, F1 into D1 plus F2 into D2, right? Now OA is common, I'll take common outside, then F1x plus F2x. Okay, now F1 into D1 plus F2 into D2, which is equal to, I'll write OA as same. So what is this? F1x plus F2x. What it will fetch now? The sum of the force, what will it give? The resultant, right? All the sum, what we get? Resultant. R is the resultant of F1 into F2 force, right? So F1x, component of F1x plus component of F2x is equal to Rx. So I'll take this as Rx, correct? ಇವಾಗ F1 force F2 force, ಅದು resultant ಏನು R, ನಮಗೇನು ಬೇಕು in x direction, so Rx, it will be Rx, right? So ಇಲ್ಲಿ ಏನು ಪ್ರೂವ್ ಆಗುತ್ತೆ ನಮಗೆ, F1 into D1 plus F2 into D2 is equal to OA into Rx. So let this be equation number 4. Now see equation number 1 and 4. Equation number 1 is, I'll write down again, R into D is equal to OA into Rx, equation number 1, and equation number 4 will be F1 into D1 F2 into D2 is equal to OA into Rx, correct? So here you see both are same. This is equation number 4. Since F1 plus F2x is equal to Rx, so comparing 1 and 4, what we can assume, if these are equal, this should be also equal. RHS equal idre LHS equal irutte anta artha. So R into D is equal to F1 into D1 plus F2 into D2. ನಾವೇನು ಪ್ರೂವ್ ಮಾಡಬೇಕಿತ್ತು, R into D is equal to F1 into D2, F1 into D1 plus F2 into D2, ನಮಗೆ ಅದೇ ಸಿಕ್ತು. R into D is equal to F1 into D1 plus F2 into D2. Hence it is proved. So this is how we proved the Varignon's theorem. So problem ಇದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಾಗ ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡೋದು ಅನ್ನೋದು ಹೇಳ್ತೀನಿ. ಓಕೆ, ಸೊ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೊಟ್ಟಾಗ ಇಟ್ಸ್ ಪ್ರೊಸೀಜರ್. ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ವಿಲ್ ಗೋ ಫಾರ್ ಪ್ರಾಬ್ಲಮ್ಸ್, ರೈಟ್? ಸೊ ಏನು ಕೊಡ್ತಾರೆ, ಪ್ರಾಬ್ಲಮ್ಸ್ ಏನಾದ್ರು ಕೊಡಲಿ ಅವರು, ಯು ಜಸ್ಟ್ ನೋಟ್ ಡೌನ್ ವಾಟ್ ಐ ಆಮ್ ಟೆಲಿಂಗ್. ಸೊ ಲೊಕೇಟ್ ದ ಮೂಮೆಂಟ್ ಸೆಂಟರ್. ಫಸ್ಟು locate the moment center which will be given in the question. Okay, next ಏನು ಮಾಡಿ, ಇದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳಿದರೆ ಫಸ್ಟು ಮೂಮೆಂಟ್ ಸೆಂಟರ್ ಯಾವುದು ಅನ್ನೋದು ತಿಳ್ಕೊಳ್ಳಿ, ವಿಚ್ ವಿಲ್ ಬಿ ಗಿವನ್. ನೆಕ್ಸ್ಟ್ ಫೈಂಡ್ ದ ಮೂಮೆಂಟ್ ಆಫ್ ಆಲ್ ದ ಫೋರ್ಸಸ್. ನೆಕ್ಸ್ಟ್ ಫೈಂಡ್ ದ, ಐ ವಿಲ್ ರೈಟ್ ಡೌನ್. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್, ಫೈಂಡ್ ದ ಮೂಮೆಂಟ್ ಆಫ್ ಆಲ್ ದ ಫೋರ್ಸಸ್ ಅಬೌಟ್ ದ ಮೂಮೆಂಟ್ ಸೆಂಟರ್. ಸೊ ಎಲ್ಲ ಫೋರ್ಸಸ್ ಫೈಂಡ್ ಮಾಡಿ, ಆಮೇಲೆ ಮೂಮೆಂಟನ್ನು ಫೈಂಡ್ ಮಾಡಿ. ಇಫ್ ಫೋರ್ಸಸ್ ಇನ್ಕ್ಲಿನೇಷನ್ ಇದ್ರೆ ಏನು ಮಾಡಬೇಕು, ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದ ಇಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸೆಪ್ಟ್, ದಟ್ ಈಸ್ ಸಮೇಷನ್ ಆಫ್ h = 0, ಸಮೇಷನ್ ಆಫ್ v = 0. ರಿಸಲ್ಟೆಂಟ್ ಬೇಕಂದ್ರೇನು, ಸಮೇಷನ್ ಆಫ್ h² ಪ್ಲಸ್ ಸಮೇಷನ್ ಆಫ್ v². ಥೀಟಾ ಬೇಕಂದರೆ tan inverse ಆಫ್ sigma v by sigma h. So this is formula based on the equilibrium concept. ಗೊತ್ತಿಲ್ಲ ಅಂದರೆ ಮೀನ್ಸ್ if they ask giving only the forces, then you have to try this. If not, directly find the forces into the distance, you will get the moment of all the forces. Okay, now from Varignon's theorem what we'll get, this if they tell to us the distance d, then moment center at all the forces divided by r. So this is the algebraic sum of all the moments divided by the resultant r. We'll get the distance d from the moment center to the resultant r. You just note down while we do the problem, it will help. Now next, if they tell to find the distance, this is the formula. Next, if they tell to find x-intercept, what is the formula? Moment center divided by summation of v. If they tell us to find y-intercept, then moment center divided by summation of h. So please note down these points. If they tell to find us the distance of the point of the moment point center, okay, like the previous in the theorem we saw the O is the moment center, like that. If you want to find the distance from the moment center to the resultant r, then this is the formula, that is moment center, how much value we got for the moments, divided by r, will get d. If they tell us to find x-intercept, then moment center divided by, if we want x-intercept, we have to divide by summation of all the vertical forces. If they tell us to find y-intercept, we have to find mc divided by summation of all the horizontal forces. So this was about the Varignon's theorem, and this was about these are all hint. Okay, this will be understand when we go through the problem. So the problem part I will take in the next class. Thank you.